Welcome to our NPTEL lecture on DC microgrid system. Today we shall cover the microgrid and its distribution generation. So, one of the major development in modern decade or the past 2 decades are the solar energy penetrations, and due to that distributed energy system predominates. You can have a rooftop solar system, you have a park carrying solar system, there are so many solar system and micro turbine and the wind turbine system, that can be your distributed generation. And thereafter we will see that its application in this distributed generation in microgrids, how it can be made for each other or they are quite applicable there as a DC source. Types of the distributed sources that we will discuss, and we shall find that energy storage technologies, because solar is not available throughout the all over the time. So, for this reason we require to have a storage element. So, distributed generation is any small electric power system. Generally, in case of the, since we are talking about the microgrid, of course, we can have a megawatt level solar power plant, but that not is a criteria. Here we have a small tiny solar power plant. Small electrical power system independent of the traditional utility grids, which is located at the user side to meet the user's end demand. That can be isolated island, that can be a ship, it can be anything. So, DG comprises of the following thing. You may have a internal combustion engine as a diesel generator as a backup. We are gradually phasing off this entity, considering that increasing the carbon footprint and everything. Micro turbine and the fuel cell, small hydropower system, small or micro, solar photovoltaic generations, wind generation, waste generation and the biomass generation. So, and this is the distributed energy system. You have a wind, you have a solar, and maybe you are connected to the grid historically, and thus you have a grid, and it may have a failure and you require to meet the contingency like hospitals. For this reason you got a internal combustion engine, and you can have a thermal stage also for the reactor and chiller, thereafter micro gas turbine, all can come and contribute as your distributed energy system. But predominantly, since we are going towards the green solar, wind and micro hydro, thereafter waste generation and biomass are the contributors. Now, distributed sources, that is DR, refers to the combination of the DG and the energy storage element. Mostly these are batteries, and this is actually DR consisting of DG and ES. It includes all DG technologies and can store energy in battery, flywheel, regenerative fuel cell, superconducting magnetic storage devices, even very high ultra capacitor, etc. Distributed energy resources, that is DER, is generation of electricity or the heat at the distribution level for local use mostly. It includes all DR technologies and system connected to a utility grid with which user can sell surplus utility to the grid. That is something that in a bright sunny day you may be off, or you went to the office, but your solar installation is generating power. So, you can sell it to the grid. Comprehensive and efficient energy use. With small size and high flexibility, a distributed energy system can satisfy the load demand and also solve the difficulty of long distance transmission of cooling or the heating sources. Because actually there is a, let us talk about the traditional coal based thermal power plant. If you wish to put into the operation, it require 6-hour time for preparation. So, for this reason you require a long transmission line cooling and the heating resources. So, these are the issues that we can get rid of. This is something like that, it can be start very fast and play into the operation very fast, and also its payback time in terms of the economy is quite fast. Efficiency of the distributed energy can reach 80% without transmission loss, since there is no transmission. And talking about distribution level efficiency in India, because of many reasons, are below 60%. The improvement to the grid security and the stability. Deploying a distributed energy system on the user side as a supplement to the microgrid can significantly enhance the reliability, continuity of the power supply to the critical load in the event of the grid collapse or catastrophe or disasters such as earthquake, snowstorm, sabotage, where even you can have a total grid failure that is happened, that is called the northern grid was totally failed in 2012. So, in that kind of circumstances, your microgrid is quite immune and it is self sustained. Characteristics of the distributed energy system. So, one is small capacity. So, since it is we are telling the term micro, so it should be it should have a small capacity, and it will cater a small area. For this reason, and low initial investment, that is one of the way, that is payoff is faster, no long distance transmission losses and investment on transmission and the distribution network. So, you get rid of your big bulky transformers as well as your switch gears, and all those issues are not required, because that itself take a place. And ability to meet special demand. So, for example, you may have actually some kind of local necessity, you are organizing some kind of festival. So, there you can arrange and power can be then channelized to this particular point, and thus you can make its own arrangement instead of depending on your utility. This obviates the need for long distance and distribution and causing no feeder loss, requiring no investment on T&D network, and contributing to good economy and the contributing to the good economy and flexible, energy efficient, comprehensive service to the end user. So, your burden, centralized burden has been reduced, since you have actually distributed the network and your burden been distributed. Local body will take care these issues. Characteristics of the distributed energy system. Environmental friendliness, mostly we are going towards green. We shall use mostly the wind and solar and biomass. Diversified energy mix, a new way to utilize the renewable energy. Using clean fuel as energy source, a distributed energy system is environmentally friendly. They have smaller capacity and suitable for integration with the renewable energy sources. Now, characteristics of the distributed generation system. In general, DG has many advantages. However, at some time it has difficulty in control system and random fluctuant behavior in nature. For example, all of a sudden setting comes and wind has got its erratic profile, wind speed can change any time. So, considering those input fluctuations, we control system take the pain of this input fluctuation. For this reason, it is a very challenging aspect to design a control system for the DC microgrid. Thus, higher penetration of DGs may jeopardize the grid stability. That is something because it downgrade the inertia. More and more penetration of the solar inverter will actually bring down the level of inertia into the grid. Microgrid controls DG, ES and the load coordinately with the control systems forms a single controllable power source and is directly arranged as in a user side. So, that is the one of the aspect. So, you just do not do the centralized control like someone tasked to maneuver actually in case of the big utility, some generator will basically fix up the problem of the voltage sag, some will fix up the problem of the frequency deviation or the frequency dip or drooping. So, instead of that you put everything in the consumer side, ultimately the consumer has to manage whole utility. So, this is the one of the aspect, you shift your responsibility to your end user. Microgrid is a controllable entity for the grid and for the user side. It can meet its unique demand, reduce feeder loss and ensure local voltage stability. ES and DGs are combined to address the problem of significant fluctuations of the DG outputs. That is one of the consideration that you have to keep in mind. DG can be connected to the grid through the power electronics to regulate the active, reactive and the voltage output for the distributed generation for improving the grid reliability. So, power electronics plays a huge role in case of the microgrid, since all this DG has to be integrated via the power electronics devices. Solar, it has to have a solar inverter. If it is a wind turbine and it is a DFIG, you have a front end converter and the back end converter fitting rotor side and the stator side, and thereafter it will connect it to the grid. So, you require huge application of the power electronics in the microgrid. Small combined heat and the power plant are generally located in the heat load center. For example, air conditioning and the power supply in a commercial building results, electricity and the heat is fully utilized. So, that is something you have to keep in mind. In case of the grid failure, microgrid can operate in islanding mode, that is quite important to ensure power supply reliability mostly to the critical load. Now, let us come into the different type of distributed generation. So, one is definitely the photovoltaics PV, it is quite common. PV means the electricity generation by direct conversion of the solar energy to the electricity. So, what does that actually leaf does? You mimic this characteristics. Solar cell is a core component of the light to electricity conversion. Currently, crystalline silicon cells is the dominant type in the market. You have generally three types of the solar photovoltaic cell. Cheapest is the thin film, but efficiency is less. Thereafter, it comes to be the polycrystalline, thereafter monocrystalline. We are going towards increasing efficiency and the cost. So, monocrystalline are the costliest, having highest efficiency. Thereafter, we have a polycrystalline, it is the middleman in the road, medium efficiency and medium cost. Thin film, least efficiency and the least cost. So, the silicon solar cell dominate the type of the market, and other type includes amorphous silicon thin film cells and compound thin film cells. This will have a lower efficiency. A PV power system may operate independently or in parallel with the grid, that depends on the kind of architecture you are choosing to. Now, this is the independent PV power system. You have a multiple solar panel put into the series and parallel, meet a particular current and the voltage demand. This is a combination box, combines multiple wires of the solar array with the circuit breaker and fuses. Thereafter, solar charge controller to disconnect the switch. Then you have a DC lighting arrestor or the charge controller. Thereafter, you have charge controller to the battery to disconnect switches. You have a lot of parallel operation. Then you have separate display to control unit. Thereafter, this is the heart of the power electronics, that is the solar inverter. So, solar inverter will convert. Till now this portion was DC, now it will convert to the AC. Generator to inverter, disconnect switch if you require to disconnect. Thereafter, this is the generator, you may have a diesel generator, wires for the automatic generators starter system when actually power goes off, inverter bypass switch to select the output in either inverter or generator. If you have a sunny day, then of course it will run from the solar, otherwise it will require to run from the generator, or the night time, or when it is night time it may run from the battery also. So, storage element, and thereafter to the load and appliances, and you have some protective devices like lighting arrestor. This is the independent PV system. So, there is no connections with the grid or it is in a standalone mode. Now, so let us discuss about that independent PV system. An independent PV solar system is a power system which is not connected to the grid system and mostly deployed in a remote off grid areas to meet local demand. Mostly this will be in a isolated island, like in a Uttarakhand there are many villages. So, they require this kind, and it may be a good tourist spot to harvest. For this reason, we may have this kind of system. The independent PV power is implemented with the energy storage ES to supply the load in case of lack of PV power generation. As shown in figure 2, an independent PV power system consisting of solar array, DC combiner box, charge controller, battery off grid inverter and AC distributor services will be the part of the system. In this case, the PV system is connected to the grid and inject power to the grid. Grid connected PV power system can be further divided as distributed and centralized type. The distributed type is a type of the DG in microgrid in which electricity is directly distributed to user and surplus or deficit may be regulated from the grid. So, once you have a energy surplus, you sell it to the, you have a bidirectional metering. So, you sell it to the grid, and once you have a deficit, load is more, you take it from the grid. For example, in IIT Roorkee putting every solar system into the grid, ultimately we require to pay our electricity in a balance of payment. This amount of energy we have injected into the grid and this much we are consuming, balance required to be paid. Whereas, the centralized type of directly inject the power to the grid to the distribution network, our IIT system is this. Now, let us come to the another important entity of the distributed generation, that is the wind power, but it required to be available in the seashore or those areas. Wind energy is a clean renewable energy. Wind energy, the kinetic energy is converted to mechanical energy by the rotor, and then mechanical energy is converted to the electrical energy by generator. Wind power system also can be classified as independent and grid connected type. So, this is the system, you have wind power, thereafter we may have a rectifier, we may thereafter controller. Essentially it is the controls the flow of this power, because if there is a extra, this is something like called wind farm commitment. So, if load does not require that extra power, it will be put into the battery, and ultimately this will be monitored by the controller. Thereafter you have a off grid inverter, then you have a distribution box of AC, and you will feed it to the load. So, this is kind of structure of independent AC power system, and essentially these are the entities of the AC power system. An independent wind turbine, we have not considered, we have considered PMSG. If it is a DFIG, then we have a rotor side converter, we have a stator side converter. An independent wind power system is not connected to a traditional electric power system and is mostly deployed in remote off grid areas to meet the local demand. ES is used to compensate the power fluctuation due to the intermittency of the wind speed in nature. So, then you have this wind generator, thereafter you have AC to DC converter, then you may have a battery storage element, and thereafter it is DC to DC converter, DC to AC converter, and connect to the grid. This is the schematic diagram of grid connected wind power system connected via inverter, and this is for permanent magnet synchronous generator. If it is DFIG, then we require to have a different architecture. We have a rotor side converter, stator side converter, then both will generate power and feed to the grid. Now, grid connected wind power system, it can be done 3 ways: direct connection. So, with a gear and all those things, it required to be synchronized with the rotating speed, so that you generate 50 hertz supply, and generally it is not been done, efficiency has been sacrificed a lot. Connection via the inverter. So, inverter will first convert into the DC, thereafter it will be connected to the grid as the frequency and the voltage require, and it can have a hybrid mode also, that we will see, and figure 5 shows that the block diagram of the direct connections of the wind turbine. You got a asynchronous generator, thereafter you know it will be generating based on the gearbox the same frequency, and it will be directly synchronized to the grid. Now, this is the DFIG if we use, that is what I was saying, that is double effect induction machine, where we can feed both rotor and stator, is connected to the grid in the hybrid mode. That means the stator is directly connected to the grid, while rotor is connected to the grid side inverter. Since it sees only the slip power, rating of this converter is quite low. The schematic diagram is shown here. Ultimately, this is the blades, and this is the this is a stator. Stator directly feeds to the supply or the grid, and we have a rotor side collection, and that will take out power or it will inject the power depending on the whether it is running in a subsynchronous or supersynchronous speed. So, it will above the base speed or the lower the base speed, and it will absorb or power from the rotor and inject, or it may absorb the power from the grid and inject to the rotor. So, another important aspect is a fuel cell, nowadays actually is dominating. Fuel cells is a electromechanical devices, produces electricity without combustion by combining hydrogen and oxygen, produce water and heat. This produce zero or very low emission, especially the byproduct is water, especially greenhouse gases depending on the fuel used, have few moving parts and thus require a minimal maintenance, reducing life cycle costs, energy production, and it can be used for the combined heat and the power. Further it increases the efficiency of the overall energy production. So, this is the hydrogen tank, they have the catalysts, and this is a proton exchange membranes and catalyst, and this is the oxygen from the air. Ultimately it will generate heat and electricity and power, and it will exhaust mainly the water vapor. Fuel cell uses hydrogen or hydrogen rich fuel and oxygen to create electricity by electrochemical process. So, it is something like we can say the liquid battery or the fluid battery, but power density is quite low of this thing. A single fuel cell consists of electrolytic sandwich between two thin electrodes and porous anode and cathode. Hydrogen is fed to the anode where the catalyst separates the hydrogen negatively charged electron from positively charged ion or protons. At the cathode, oxygen combined with the electron, and in some cases with such protons, water, and resulting the water or hydroxide ions respectively. Electrons from the anode side to the cell cannot pass through the membranes to the positively charged cathode. They must travel around or via the electric circuit to reach the other side of the cell. This movement of the electron actually cause the electricity into the outer circuit. Classification of the fuel cell, there are many fuel cell. So, we are not going to that detail, but just we are pointing out alkaline fuel cell, that is phosphorus fuel cell, polymer electric membranes fuel cell, molten carbonate fuel cell, solid oxide fuel cell. It is based on the fuel and oxidant, hydrogen pure and oxygen pure fuel cell, hydrogen rich gas air fuel cell, ammonia air fuel cell, synthesis gas air fuel cell, and hydrocarbon gas fuel cell. So, these are many entities that you can look suitably. So, this is a part of the chemical engineering. For this reason, this is a multidisciplinary subject. Ultimately, this part required to be contributed from the chemical engineers. So, energy storage along the renewable energies, renewable generators, PVs and wind is required to increase reliability and the flexibility. So, the intermittent nature of the renewable energy sources like solar, wind needs a storage to deliver the right amount of power and quality also. Energy storage is used to enhance the stability and the efficiency of the microgrid by decoupling generation source from the load. So, the ESS stores excess renewable energy and supply the load where renewable energy is low. So, this is the overall classification of the storage element. You can have electromechanical storage element. So, that is pumped hydropower stations, we have in Purulia in West Bengal, compressed air, fuel, and thereafter you may have electromagnetics, you may have a superconductor, you may have SMEs, thereafter we may have a electrochemical, that is hydrogen, power to the gas, flow battery. So, there are different kind of flow batteries, vanadium redox, zinc bromide, polysulfide bromine. So, these are all the chemical process where chemical engineers have a say, and others are battery. Batteries can be lead acid that was properly used, but due to the lead we are trying to get rid of it. Now, you have a nickel cadmium or lithium ion or NAS, or you may have a thermal storage also, sensible heat media, molten salt, latent heat media or chemical heat media. These are all can be used as per the suitability, but mostly we will talk about this, considering that it is our electrical engineering domain, that is batteries. So, what we can say from that chart, energy storage needed for consistent operation of the renewable energy system in DC voltage regulations, because we are talking about the DC microgrid, it is same for the AC also. The load and the renewable energy source power generation profiles are the main important factor for determining the kind of energy storage. Several technologies for energy storage are available, among which battery have been used extensively in microgrid application. That is what I was saying, that grid find is more applications in microgrid. Thank you. Thank you for your attention. We shall continue our discussion on the microgrid, DC microgrid in our next class.